Hi everyone, I'm Dr. Surjit Singh. In this video on Python via examples, we shall extend our previous program on Sudoku solution. Let us begin. In this session, we will extend our Sudoku solution by expanding the fill sure cells function to include two more cases. One of them is about finding the only cell for a choice in a row, column, or a box, and another one is based on the paired pair of choices. These functions help us in avoiding the depth-first search as long as possible. We will learn about these by examples. In our previous video on Sudoku, we developed a function to fill sure cells, the cells that have only one choice. We'll extend that code now. This is the program structure that we used. For a given grid, unfilled cells are saved as 0 in the memory. For details, please refer to the video 24 of this series. Within the function fill sure cells, we formed sets for the rows, column, and boxes. For the filled cells, we used note down entries to add them to these sets. We used these sets to find the choices for all the unfilled cells and saved them in the dictionary of choices. Each unfilled cell has an entry in the dictionary. Instead of showing the choices separately, we show them inside the grid itself. However, for the unfilled cells, the grid values remain 0. We also wrote the function to find cell with minimum choices. Execution of fill sure cells begins with setting up of these sets for all the filled cells and the dictionary of choices for the unfilled cells of the grid. If the cell with minimum choices returns a cell for which number of choices is just 1, we enter a while loop. We save the single choice in the grid, remove it from the dictionary and note it down in the sets. We delete it as a choice from the remaining cells in its row, column, and box. We revise the cell with minimum choices. Upon removing 3, some of these cells are further left with single choices. We remain in the while loop and repeat the process one by one for all such cells. When there is no cell that has a single choice, the loop terminates and we return the cell with minimum choices to DFS that tries all of its available choices and backtracks the unsuccessful attempts. This summarizes the video 24 of this series. Let us now avoid the Tukka solution of backtracking and apply some logic to stay in the while loop. We will reach the return statement only if all our logics fail. We stay in the loop if num choices is 1. If not, we think of a simple logic to avoid reaching the return statement as long as possible. We notice that out of all the unfilled cells of row 0, 02 is the only cell that has 6 as a choice. So we must fill this cell with 6. Similarly, in the last column, 8 is the choice for only one cell. We must fill this cell with 8. Likewise, in box 6, we can place 4 only at cell 8 too. To handle such cases, we now create the function found_only_cell. If a cell with unique position is found, this function returns true. Revised value of number of choices becomes 1 and we stay in the while loop. We define this function found_only_cell just before the function cell with minimum choices. Fill sure cells is its holding function. Let us now write its code. In the first loop, we scan the rows of the grid. For each row, we scan the values from 1 to 9. Set row has 5 and 7. 1 is not present in it. We save 0 as initial value of count and 99 for the cell found. We scan all the cells of the row. For column 0, cell is 00, which is already filled. So it is not in the dictionary. In the next iteration, column is 1. Cell 01 is present in the dictionary, but val is not one of the choices of this cell. 1 is not in the choices for two more cells. Val 1 is a choice for cell 04. We increase the count by 1. Cell found becomes 04. Next three cells also have 1 in their choice sets, so its count becomes 4. Last cell of the row is already filled, so it is not present in the dictionary. One of these 4 cells of row 0 will finally get 1. The count is not 1, so we try the next val, that is 2. Count of val 2 is 3. Count of 3 is 5. Loop continues. When val is 6, the count is 1 and the cell found is 02. Therefore, we revise the choices of cell 02 to 6 only and print the message for this successful change. As a cell with a single choice is found, we terminate the execution of the found only cell function and return true. Fill sure cells takes control of the execution. It continues in the while loop because num choices has become 1. Next iteration of the loop begins by filling the cell 02 with 6. In some other problem, if no row has a single cell position for a val, we try the columns. 1, 2, 5, 8 and 9 are present in set call 0. We try the remaining values. We complete this code on similar lines as the loop over rows. Last column has 8 at only one place. We drop the remaining choices for this cell and return true. In case all columns also fail for a problem, we try the boxes of the grid and write the loop over boxes on the same lines. Box 6 has a distinct place for 4. We revise its choices to 4 as the only value and return true. If any one of the 3 loops return true, our logic works. If for a grid all the 3 loops fail to find only cell for any value in the entire grid, we have to return false. Execution goes back to the function fill sure cells. If it receives true, we fill the found cell with the only choice present there. If no such cell is found, the function is false and we have to resort to DFS and backtracking. Another logic that we often apply is of paired pair of choices. In row 7, pair of choices 3, 7 is present twice. This means that for these two positions, one of them is 3 and the other is 7. So we must remove 3 and 7 as choices from all the remaining cells in the row. This leaves the cell 76 with only one choice, that is 9. We can try same logic for columns and boxes. For box 8, choices 1 and 7 form a paired pair. If we remove 1 and 7 from choices of the remaining cells, 2 more cells are left with single choices. To handle such cases, we create the function paired pair of choices. Let us now define this as another function within the function fill sure cells just before the function cell with minimum choices. We start with scanning of rows. We set up a new dictionary for pair of choices. We scan all the cells of the row which have only two choices and save their counts. Both 1 8 and 1 4 are present once in the row. We inspect each pair in the dictionary. Neither 1 8 nor 1 4 is present twice. For next row, there is only one pair. Process continues. For row 7, there are 4 pairs, out of which the pair 3 7 is present twice. We process this case further. We print the pairing message and scan the choices once again. 3 cells have choice sets that are not the pair 3 7. Out of these 3 cells, one has 3 or 7 present in its choices. So there is a scope for reducing its choices. On subtracting set 3 7 from set 7 9, we are left with only 9. Length of the reduced set of choices is 1. This means that we are sure about filling the cell with 9 and we return true. Next loop is for columns. It looks like this. And the third loop is for the boxes. If none of the loops return true, we come out of the 3 loops. In this case, we return false. There are ample opportunities for a grid to return true. If returned value is true, we stay in the while loop of the fill_short_cell function. Often, the loop continues till we obtain the final solution for the grid. Sometimes, paired pair of choices does compression that reduces the number of choices but not to a single choice. In such cases, another round of found only cell is sometimes helpful. More logical decisions can be incorporated in the same way at this place. They may take some more of execution time, but we are able to record the basis of filling of the cells as against the DFS backtracking, which is a tukka filling. However, backtracking cannot be completely eliminated. We have to keep it as the last resort. As we run this program for any given Sudoku problem, the output will not only give the final solution, but will also give reasons for filling of its unfilled cells. For most of the problems, we are able to fill the grid without any need of backtracking. This is the output for the present example. To begin with, we fill 6 single choice cells. In the output, we start the counters with 1 and not with 0 for the convenience of the user. We called the function found_only_cell to fill 6 at cell 13. In between the execution of fill_short_cells, we call the function found_only_cell 3 times. The loop continues till we finish the filling of the entire grid without any need of backtracking. In this session, two functions that we developed are about finding the only cell and about paired pair of choices. In the function found_only_cell, we find a cell that is the only place for a choice. In paired pair cell of choices function, we delete the two choices from the rest of the cells and identify a cell that is left with a single choice. These two functions help us in filling the cells and avoid DFS to a great extent. I hope you enjoyed the video. Feel free to ask for any questions on my email address given below. I'm waiting for your comments. Please stay tuned for more such videos.